The last angle relationship we're going to talk about today is consecutive interior angles. Okay, this is kind of the odd man out. The other three, we know they're like when we have parallel lines are congruent. This one kind of is a little bit different. We'll talk about that in a minute, but I wanted to kind of just fuse in your mind that consecutive interior angles is different than the other three. So consecutive kind of means like next in a sequence, or like next to each other in like a list or something like that. So when we see consecutive in terms of angles, we're talking about like kind of the one that's next to it, an angle that's next to it. So this basically, for our purposes here, means same side of the transversal. Okay, and interior again means between the lines, and exterior of course means outside. So consecutive interior means they're in between the two lines because they're interior, right, in the blue area, but they're on the same side. So if you were like counting angles, you'd be like that one, and then that one's kind of next as you come around. So they're on the same side of the transversal, but they're inside the two lines. So those are consecutive interior, and those are consecutive interior. Again, you don't have to have parallel lines to have consecutive interior angles. You just have to have two lines cut by a transversal. They don't have to be parallel. So here's the consecutive interior pairs. Now, if they are, if the lines are parallel, then you get a bonus. You get an extra piece of information. But it's not that they're congruent, and that's what was true for the other three. In the other three situations we saw, in the corresponding angles, in the alternate interior, and the alternate exterior, if the lines were parallel, then those angles were congruent. In this case, they're supplementary. Right? Two parallel lines cut by a transversal, then the pairs of consecutive interior angles are supplementary, which means they add to 180. Now, if you think about it, and you think back a little bit farther, this is basically the converse of Euclid's fifth postulate. Okay, Euclid's fifth postulate was that if these two angles add up to 180, then the lines are parallel. So if they're supplementary, then they're parallel. Right? This is if parallel, then they're supplementary. So it's very, very similar to Euclid's fifth postulate. We're actually going to go through and prove this tomorrow. But right now we just kind of want to get an idea for the names and the relationships, and then once we're comfortable with that, we can go through the process of proving them. Okay? So supplementary means they're going to add up to 180. Notice they're not congruent this time, so be careful there. And that's going to come into play down here when we set up and solve our equation. So in the other equations that we did, the other problems that like this, we set these equal to each other, right? In this case, we are going to add them up to 180. And as I'm looking at this, I obviously used this multiple times and just erased the pieces that I need. We want to write the consecutive interior angles theorem. Right. So we have four theorems. We have the corresponding angles theorem. We have the alternate interior angles theorem. We have the alternate exterior angles theorem, and we have the consecutive interior angles theorem. So there's four definitions. There's four types of angle relationships. There's four theorems, one to go with each of those sets. So we're going to use that theorem right here in this guy, but we're not going to set these angles equal to each other this time. We are going to add the two angles together, or add their measures together, and set that equal to 180 degrees. Okay, so let's combine our like terms. We're going to get 33x here. When we add these, we're going to get 15. That equals 180. Okay, so we'll subtract 15 from both sides. And we'll get 33x equals 165, and I hope we did this right. Hopefully 165 is divisible by 33. It is, thank goodness. X equals 5. Okay, now that's not our answer. We definitely needed that, but we got to go one step further and we got to say what these are. Now, in the previous examples that we did, we knew those angles were going to be the same because they were congruent. In this case, they're not going to be the same. but they should be supplementary. So we're actually going to need to plug this in twice. So we're going to do 20 times 5 plus 9, and then we're going to go 13 times 5 plus 6. Okay, 20 times 5 is 100, so that makes this top angle 100 plus 9, or 109 degrees. And then 13 plus 5 is 65, and then we add 6 to that, we get 71. And 71 plus 109 is 180, which is exactly what we want here. So that's kind of a second check to make sure that we did this right. We get supplementary angles. Okay, so that's consecutive interior angles in general, and then here's this consecutive interior angles theorem, which holds true when these are parallel. You get supplementary angles.